Hey everybody, Adam Savage here in my cave with another one-day build, and this is a prop replica. It's kind of a prop replica. Actually, it's not a prop replica because it's a piece of a prop replica. Okay, Ghostbusters Ecto Goggles. These are the goggles that Dan Aykroyd wears in the first Ghostbusters film. Uh, they are built off of a pair of old night vision goggles, a military issue night vision goggles, I believe. And this is the correct plastic frame that is the basis for those goggles. Now, I had one of these cast in resin, and it fell off my shelf and shattered. So I needed a new one. Rather than buy a casting, it turns out a friend of mine had one of the correct shells and lent it to me. And I was going to make a silicone mold of this. I was going to make a kind of an open slush pour mold that I could cast in onyx and kind of get the shell thickness. But honestly, this thing is super thin. This thing has got to be what, 40 thou, 70 thou. This is 70 thou, 70 thousandths. It's very thin. Casting something like this is not easy. It's done. Some people do it. It doesn't matter that much if it's a little extra thick, but it becomes a delicate part, as evidenced by the one of mine that shattered. So then I thought, maybe there's a better way to make this. And I looked at it and I realized, well, this is actually a pretty simple shape. I could probably vacuum form it. So that is what I'm going to do. I am going to take these goggles, get some B-roll of it so you can understand the contours and the topography of this thing. I am going to take these goggles. I'm going to make what's called a buck. I'm going to make a negative form that perfectly fits the inside of this that will allow me to pull it. It is just big enough, I think, to pull on my mini vacuum former. So we'll get to see that whole process play itself out. Now, to make this buck, I could use a lot of different things. Well, hell's bells, Margaret. I could even tape this up and fill it with plaster and use the plaster as the buck. But that's not what I'm going to do. There will be artifacts to that will require some cleanup. It won't be a super robust buck, so I'm not going to do that. I am actually going to hand make it out of some effectively foam urethane known as wrench shape. This is a expensive model making material that I've used in little chunks in the past. But a few years ago, I got a beautiful cachet of some heavy duty wrench shape. I mean, this is like, if you're a model maker and you see this, you're like, damn, that is like an expensive piece of urethane, but it's awesome. So let's talk about wrench shape for a second. Wrench shape it's a prototyping material. It is, like I said, it's a urethane, petroleum-based plastic, and it carves very easily. If you see, I've got an X-Acto blade here. I can just carve chunks. So it carves kind of like pine, like a simple pine wood. The difference between this and pine or particle board is also similar weight to lightweight particle board, MDF or LDF. The difference between it and those materials is when you have particle board, you've got a surface of the particle board that's great, but as soon as you cut the edges, those edges, they soak up paint, they need finishing. This is monolithically uniform. So no matter where I cut it, it is going to have the same grain and same texture. So this is a fantastic modeling material. Wrench shape is used in industry. Often when you set up a CNC machine, you want to make sure your part's right, but you don't want to run it out of a giant billet of aluminum right off the bat. You run it in wrench shape. It doesn't dull your tools. For vacuum form bucks, it's almost de rigueur in the special effects industry. For little tiny detail parts, there are few other materials that are as much fun to work with as this. And if you work for an architectural modeling firm, sometimes you can get scraps of this out of the dumpster. Us model makers at ILM used to pull little scraps out of ILM's dumpster or garbage can all the time. So I am going to take this giant chunk of wrench shape and I am going to make myself, I've got just enough room. I'm going to make myself a buck that is the exact shape of this thing. we've taken all the measurements that we can. We've made all the modifications that we can. And I think that I have successfully created the correct topography to obtain the shape that I want. Get around that business. And once I have that, then I'm going to super glue all of these pieces together. And then they will be my vacuum form buck. So if everything goes right, we should be able to pull this vacuum form in a few solid minutes. Yeah, no, it's that fast. There's the thing. Since I'm going to be pulling, since I'm going to be pulling a vacuum form, I'm going to end up drilling some little holes around in here in order to allow the vacuum to pull the plastic into the cracks there. That's really important to me. However, I'll need to like mill out a manifold down here in order to accommodate it. So that's what I'm going to do right now. I'm going to just do some milling and shaping and gluing to get this all together. Here is what I started with. This is what I wanted to replicate, a thin plastic shell for my Ghostbusters Ecto Goggles. And this is the buck that I have made that when I pull hot plastic over it should give me this shape. I have done some things to allow the air to move better. I've drilled holes in the corners here. That should allow the vacuum to pull the plastic into the corners. I've done a little bit more of that here and there. We will see. Sometimes you have to modify a buck after you utilize it. You got to try a couple things out. I am also going to pull out some talcum powder, which is like talcum powder acts as a lubricant for these bucks. So I'm going to bring the vacuum form over here. Yeah. Right. Actually, it looks like I pulled this thing apart to do some work on it. So I'm going to need to do some work to get it back up and running. Here we go. Vacuum form. I've got a piece of black styrene. I've got my frame. I had a metal frame for holding my vacuum forming, and it's gone. Now it's not gone. I'm just not sure exactly where the hell it is. And the reason I don't know where it is because I was planning on rebuilding it. So that may end up being something that I do. But for right now, I'm going to put this piece of right now, I'm going to put this piece of plastic into this frame and screw it down. And that will be enough. The real trick with vacuum forming is that you want your frame to be holding on. I know this is a freaking disaster, but it should actually work. It should actually work. Just got to go gingerly. We're going to get one pull out of this before I have to rebuild the vacuum form table, but I will. Okay, so this was a quick and dirty fix a while back. We're doing it again. Yep, there we go. That's good. Yeah, I'm going to go here. Yep. All right. This is touch and go. I'm improvising because I don't have I didn't know my vacuum former wasn't ready for prime time. The thing is that I have this lovely little vacuum former, and I'm very proud of it. I'm very vacuum forming proud. But it's not a complicated science, the science of vacuum forming. And in fact, if you go on YouTube, you'll find people who've built their own vacuum formers and done really respectable vacuum forming in their house for pennies on the dollar, like a very, very low cost kind of execution. with lovely results. The fact is, vacuum forming yields a product that few other inexpensive processes can yield. And it's one that I've been in love with since the beginning of model making. Actually, I think the first vacuum former I used was in Mr. Benton's art class at Sleepy Hollow High School. And we were using it to make chocolate molds to make our own chocolate bars. Yeah. High school art class, man. That is an awesome thing to partake in. Okay, so I've got my frame. It's well mounted all the way around. It is, let's see, magnets. I need some extra magnets on here to hold it up. Industrial vacuum form machines do this all. They do this all automatically. The vacuum former is composed of two parts: a heater up here, radiating heat down; a vacuum down here, sucking the hot plastic down. All you need is a piece of plastic and a buck. Here is my buck. Oh, also, everything you're working with. Actually, let me just make sure that this fits over this. Yep, it does. Okay. Yeah, you want to check all your parameters. That's really, really important. Oh, talcum powder. Yes. Cornstarch. Cornstarch works great. Cornstarch is also like a dry lube for vacuum forming. Cornstarch also works great in mold making. It tends to allow plastic to wick into the smaller parts of your molds. I might have covered that factoid before. Now this is going to get a little powdery when I pull on the vacuum form, but it will also allow some slippage of the plastic, which should help us tremendously. This is hot. So when the plastic comes down, you're going to want to use your fingers to like massage it into place. Don't, because you'll burn them. All right. I think it's time to heat up our plastic. So I'm turning on the heater. If you could see up in here, I've stretched some kiln wire across and basically just shorting it out in order to create a heater. I think it's a nichrome. I'm not sure, actually. Damn, this is a dusty piece. I think very soon we're going to have to rebuild this and make it a little more usable, because I can't be screwing 40 screws every time I want to do a vacuum form. Something to note. The first thing that happens with plastic is it bows upwards. And that's because you're heating the top layer, the top of your hand, and those molecules get farther apart. And as they get farther apart, they push the molecules, the still cool molecules underneath them, and they create this sort of dome. So that's the first thing that happens. Then it starts to buckle here. You can see now it's semi-soft. It's not really that soft. And you'll notice it start to, in the reflection here, you'll notice it start to even out. Yeah, there we go. Okay, now we're on the downward journey, and the trick is you want the amount of droop that you get. Come on, there we go. You want the amount of droop here that you get to be somewhat close to this, somewhat close to the height of your buck. That is a kind of a rule of thumb. That's the one I was taught. Sometimes I follow it, sometimes I don't. Now you can see the plastic's getting soft. The smell of heating styrene, very lovely smell. It smells like work to me. It smells like it's the smell of special effects, honestly. When we were doing, there's a episode of Star Wars Insider that Tori Belleci and I are in. And it's, So I guess I've got some dust in there that's burning a little bit. Okay, I'm going to get ready to pull this because I think my wood's heating and burning. Okay, here we go. Turning off the heater, on the vacuum form. I got some web in there. Yeah, not bad. Not bad. think I got time for one more. We'll do one more. But that was highly successful. So there you have the pulled vacuum form. My only issue is I had a big web over here. Now there is a way to deal with that, and I'm going to implement a second vacuum form and deal with that. It is also, you can get that away and paint it and get it out of your persuasion. That's certainly feasible. One of the things about vacuum forming is that you want to be able to get your piece back out of the plastic. So I'm just going to slice this open. This styrene is an 040 styrene, not a 075 or 080 like the actual piece. I think I have some of that, but we're just doing some test pulls here. Now, in order to get this off the buck, it's always really good for your big planes to have a draft angle. So it's not perfectly vertical. It's actually got a little bit of a draft to it. That draft exists, hell's bells, in all sorts of injection molded products too, because that helps with injection molding as well. Oh, it's quite thin. All right, but still, let's see. Yep, it's coming out. And the draft angle, oh man, I can't even tell you. I've broken bucks pulling them out of the plastic. Yeah, I'm pretty chuffed about this. I think I let it droop too much. However, let's do a little bit of trimming. Slice on the inside to pull that out. Oh yeah, that nose got real thin. Okay, so just to reiterate here with vacuum forming, here is the original. This is what I was hoping to replicate, and here is my vacuum form. You can see how quickly it gave me almost exactly the shape that I wanted. It is topographically really, really close, and it fits me. And I have to say, okay, so I can see that I haven't gotten that curve. So I've got to radius that edge. Yeah, I can see that. But I'm really, really chuffed with that. It is a very, very respectable first attempt. And I'm going to get some thicker plastic. I'll get this going. It is a new day. I am still super excited about how my Ghostbusters Ecto Goggles vacuum formed buck worked. Seriously, I'm like stoked to hell about it. The comparison between these two things, it is very satisfied. It's excellent work. This is a little thin, and this will not work. So it's time to talk about the vacuum form machine. This is a machine I built. You can see its first sign, the vacuum suck. The first vacuum form machine that I ever used was in the employ of Chico McMurtry, who was, Chico is an amazing artist with Amorphic Robot Works. They are out of Red Hook, Brooklyn right now. But in the early 90s, Chico had a shop down in Yosemite Street in San Francisco. And I lived in that building, and I worked for Chico as an assistant for the better part of two and a half years. And we've remained great friends ever since. But Chico had a vacuum form machine called the Vacuum Suck, and I was using it to make things like bicycle helmet props for dance shows. And I've talked about that before and tested. But my mentor in model making at the time, Mitch Romanowski, had this beautiful red vacuum form machine. And I think it's literally like the product's name was Vacuum Form, right? And these are impossible to find. They are rare as hen's teeth. If you've got one and you want to sell it to me, please reach out. I'd like to know. Um, but back in the late '90s, in the late '90s, I was working at ILM, and I was building my own little shop. I was starting to do freelance work out of my shop on Bartlett Street here in the Mission, and I needed a vacuum former. And I was talking to Fawn Davis about it, of Fawn Co. down in LA. And at the same time, Fawn was living over not far from me in not the Excelsior, but Crocker Amazon, I think. And Fawn was also building a little shop. So the two of us were building our little personal shops and our own little businesses and brands together. And we both built vacuum formers at the same time. I'm going to try to get Fawn to send me a picture of his because I think he still has it. And this is a wooden box inside of which is the motor for a shop vac, on top of which is some perforated steel plate. And then that does the vacuum of the vacuum forming. And then the forming is done by this heating element here, which is basically just some kiln wire stretched between ceramic elements and then powered at 120 volts. And this heats up enough to evenly heat plastic. And this has served me well for nigh on 20 plus years. But I have always had some issues with it. And I've always had ways I wanted to make it a little bit better. And I'm going to do some of those today. And the very first one, the most complicated part of a vacuum form machine is holding on to the plastic. If we take a look at this wooden frame that got me through the first vacuum form yesterday, but won't last any longer, what you can see is that I'm grabbing the plastic all the way around the perimeter with an equal pressure. Being able to do that with a hinged frame requires a little bit of finesse in the engineering of that, because you don't want your plastic pulling away from the frame during the form. That'll ruin everything. So I'm about to rebuild the clamp frame for this vacuum form machine using this beautiful 1/2-inch steel square tube that I've got a whole bunch of. I know that was a really long story, but it was important to give you the context for this great machine. I'm super fond of this machine. We're going to turn it into a nice bit of kit today, because the small tools, they need love too. Okay, I know I said I was working on the frame, and then I set up a time lapse and I started doing everything but the frame. But that's because I came up with a new priority as soon as I started to take this machine apart. The first thing I did was I took everything off the main case structure. So I've got a wooden box here with a steel frame for supports going to this other steel frame. I just spent a bunch of time making sure that this was level and square to itself and solid and good. Then I took off the motor, which, as you can see, this is a shop vac motor. That's the top of an old shop vac I had. And I modified a piece of plumbing pipe there to be the intake. I don't know why I just showed you that upside down. So I have some work to do on this platen here before I build the frame, because I just want to get that right. And then I also pulled out the heating element. So here's the heating element. You can really see the structure of what I did. I used some 440 all thread to support these ceramic rods that are running across 3 spots. And then I ran some kiln wire, I think that back when I did this, I specifically chose a certain amount of kiln wire to get to a certain temperature at 120 volts. There's no variac on this. You turn it on and this just glows and it heats up the plastic. So I'm loath to change it. It's been working for 20 plus years, but I am going to refine it and make it just a little more robust and a little less jank. So I'm going to get the heating element wrapped up here. Then I'm going to figure out its proper attachment to this guy, because I still think I can make it a little bit better. And then, and we'll move on and we'll go from there. heating element is in. I've included a wire travel for the back. So I've got two high temperature lamp cords going in and connecting up to the heating elements on both sides. This is all stretched out nicely. I've added in some angle iron to keep the insulation in place. I have reattached the plumber's tape connection. And now I'm about to run a test. So we're going to do a, hold on, sorry. So now we're going to do a test. I'm just going to connect up, I'm going to connect this up to house mains. And we're just going to take a look and see if anything burns that we don't want to burn. Because we're going to be running this a lot. And we want to make sure it's robust. So I'm going to, this is not plugged in. Okay, so that's insulated. That's insulated. That's insulated. All right. Yeah, we should get this. All right, here's the hum. I feel it drooping. It is all heating up red hot. Yeah, we've got a little bit of smoke here. That's fine. It's going to take a minute to burn off some of the detritus. Yeah, want to take a look? Yes, you do. Here you go. See that? All right. So, yeah. Oh, got a little bit of smoke there. Let that play itself out. Let's just see and make sure that we're happy with how it's functioning. I don't like how dim that one is there. It just means that it's not an even heat, but that might not be mission critical. All right, I think I can move that one closer out there. But for the most part, I think it's right. Clearly, these are better when they're touching the padding. So I'm going to endeavor to get them all to be touching the padding a little bit better. But we can now dismantle that. And now this is a safe device. So I'm going to undo these wire nuts and take these off. And that is the heating element sorted. Okay, so now, and I really like this. I've got this nice, neat travel down the side. Everything is insulated away. There's nothing to catch on anything. We have power coming in. We have power coming down. Now it's time to start to work on the plate. So I'm going to move this down here. And this is my platform. See what I did here? I took a plate of aluminum and bent it at a right angle all the way down, I think. Is that what I did? Oh no, I had long, thin angle iron. And I cut it into a square and then I sealed it into this, right? So that's the vacuum intake. This is the edge of my perforated plate. There's a couple things I want to do here. One is I want to even out and make this plane super flat. That's one. Two is I want to add a couple of cross braces this way and one this way to help support the table because my table droops a little bit in the middle. And I think I would get better forms overall if I didn't have that. Then it's time to attach the outer perforated plate to this guy. I'm still using the same piece of perforated plate I bought almost 30 years ago. And the vacuum seems to work great. Still works great. Pulled a beautiful form yesterday. I don't think I need to increase the exhaust inside the machine at all. I have these two long slots here at the bottom, and that's to allow for effectively the vacuum to exhale. And I think I did the math on those. I think when I built this 22 years ago, I think what I did was I actually calculated the opening that air was intake, and I spread that out to the two slots so they have the same square area as the intake, which means they have all the outtake that they need. Outgo, as it were. All right, so I'm going to take this over to my disc sander and do some work on it. one is going to sit this way, upright, and I'm going to bend its corner so it attaches into this piece. And then these two will cross it, and they'll be tabbed and slotted together to provide extra upright support. And then I'm going to drill some holes in the sides here so that air can move freely among all of this area. Yeah, that should provide a much more flat surface for me to. Here is the 3 supports. You see how they're tabbed and slotted together. I have not yet riveted them here. What I'm going to do, I actually don't mind the clearance underneath those. That should help the air move around a bit, but I don't want to put all my eggs in that basket. So I'm going to drill a couple of relief holes in each of these spars, except for this one. And that should get me the air movement that I so desperately need. Doing one in the center and then splitting the difference on both sides. And these aluminum pieces I'm using, they're just hardware store flat bar. Whatever that ridiculous alloy they use is, that's what I'm using. All right. The reason that I'm ending up doing all of this work before I even got to the clamp frame is the fitment of the clamp frame is all important. I don't want to make it too small, and I wasn't sure if I was going to change too many parameters. So I'm taking care of all of this stuff before I go on to make the thing that fits over this. It's just a proper order of operations. But as you can see, I've now got a nice spine up the middle and 2 extra supports. I've drilled some relief holes so air can move around there. The next step is for me to take this. You can still see me, right? Ah, neat. Oh, wow. That's cool. This is called perf plate. It's perforated plate. Back in the day, in the 90s, you could walk over to a sheet metal shop down on King Street, which is now like a super fancy neighborhood. But back in the early aughts, it was just a no man's land. You could walk into a sheet metal shop and say, hey, could I look through your scrap pile? And they'd be like, sure. And you'd go like, hey, could I have this for like $4? And they're like, absolutely. And you go. Now, those days are gone. Those days are so gone. But this is the original piece of perforated plate. You can see how like potato chippy it is. I'm going to spend some time kind of bringing this back into submission, and then I'm going to attach it to this, and then we'll be able to make our, don't you fall, our clamp frame. I started working on this, and then I thought, is it possible that I don't have any more perforated plate? I mean, I try and keep a certain amount in stock, so I went looking. And I found this, which is, oh, here you go. Here, there's that. Ooh. Hi. So what I've got here is a beautiful virgin piece of perf plate. And I am going to make this my new platen. Rather than try and get this potato chip thing to behave, I'll just put this in stock. I can use it for other things later, and I'll make my new platen, my new platform out of that. Yeah. Now, you may have the legitimate question of why was my first platform for Vine vacuformer so woo? And part of it was because I had just one of those hand metal brakes, the one you saw me using to bend the crossbars. And so I had to bend this thing piecemeal all the way around with pliers and hammer and that's just a recipe for not a perfectly flat piece of metal. But in the interim 30 years since I made this, 20 years, I've got this lovely 24-inch metal brake. Let's talk about what a metal brake is. It is a machine for making creases in metal over long expanses. So these are used by HVAC people to make ducting in your ceiling. They're used by metal workers the world over. They usually come quite large, 3, 4, 6 feet long. Finding small ones, like 24 inches, and I've got one that's, I think I've got even a smaller one somewhere around here. They're hard to find. Little baby brakes are actually hard to find. A 12-inch one is just one of my holy grails. So I've cut my corners out, and now I'm going to make bends across these 4 lines and start to manipulate my piece. So the first thing that you do is you clamp in your piece where you want the bend, the bend to happen. And because I have these corners cut out, I've got them delineated. And then you simply bring up the bottom and you bring it slightly past center. Yeah, there you go. There is a perfectly smooth bend. Yes, see, isn't that lovely? I really dig that. Okay, I'm going to do the second one. Again, I wish someone made a reliable 12-inch metal brake because honestly, every maker should have a little 12-inch shear and a little 12-inch brake. I've got bigger shears. Actually I have a 6-inch shear that is just primo. Okay, so this is clamped in, bend this up. Center, just make sure, yep. Okay, and then, right. It's the finger brake, and I gotta make the finger brake work. Am I gonna, yeah, I have to make an adjustment. I had to get a tool, an Allen wrench, to make an adjustment. This is what's called a finger brake. And the reason it's called a finger brake is because it has the pieces with which it clamps down on the metal are actually adjustable and movable. So, finger brake is necessary when you're doing box construction. So I have both sides here bent up. If I bend this third side, I clamp it down, I won't be able to bend it past like there, right? Because this is in the way. With a finger brake, you can set the fingers so that they split and occupy those corners, and you can get them out of the way so you can make that full bend. It'll be a lot clearer when I show you, but what I gotta do is adjust the fingers. So, in there, and this one here, and I'm gonna expand it out just a tiny bit. This is tightened down. Yep, ready for the clamping. More tight. I'm going to clamp this piece of metal in here and show you on camera what I speak of. So now you can see my finger brake is adjusted to span the width of the inside of my platen. And because it's on the inside of these two upturned sides, when this bends up, it will clear the sides of this. Beautiful. Look at that. Look at that. It's almost like I know what I'm doing. Do the same on the other side. Clamping force. Bending force. G-force. We have our beautiful flat platen. We're going to put it in place. All right. That is great. There is a risk when you do something like this that it will not fit perfectly once you're all done. And that has certainly happened to me. How do you make sure that it fits perfectly? Well, look, it's about measuring. It's about making sure you've measured carefully. And then It's also about the institutional knowledge that you have of your device, of how it functions and how you will utilize it. Yeah, those are just the facts of making these things work. Time to attach. And we're going to do that with some pop rivets. And I'm going to do it the same way I did it before, which is to say, I'm going to do it with a hole in the center of each of the 4 sides. And that worked great for years. 1. I could use more rivets to hold this on, but I don't need them. And I want to take this apart again. Maybe it'll be 20 years before I take it apart again, but I will. So I want to make sure that I can. All right, let's just do a little bit of and there you have a, oh, look at that. I've wanted this platform for my vacuum former forever. All right, we are close to building the frame. So let's do some rough assembly and let's do an operational check. And I'm changing out how we switch this thing because I had a much better idea. In the past, on the first iteration of this machine, I had 2 switches, one for the heater and one for the vacuum. Now the heater, as you can imagine, draws a lot of power. So there was always this operation where I turned on the heater and then I turned off the heater to turn on the vacuum. Yeah. If you don't do that, you immediately blow a fuse. And then you've got a vacuum you're not pulling and you've just wasted a piece of plastic and some time. So I am replacing these 2 switches with one. I've got here what's called a double pole, double throw, 3-position switch. This should allow me to have 2 connections for the heater, a neutral position in which nothing's on, and 2 connections for the vacuum. So one switch. I can't turn one on without turning the other off. Yeah, that I think that, and I think I'll add a master power switch. And then once I have that, then I've got a reliable machine, one you can't screw up. It is impossible to make things foolproof because fools are so ingenious. That's not my quote. I got that from a book many, many years ago. I want to double check operation on this. So I'm just going to pull out audible continuity and double check the switch connections. Great. Opposite. This is exactly what I thought. Perfect. 1, 2, 3, 4. I'm going to put some, let's see, the switch I've got has these spades. So I'm going to use spade plugs. No, not the red. I think it's going to be the blue. Yeah, it's going to be the blue. Okay. My biggest problem with wiring is I always clean up too soon. I clean up too far before the system's checked, and then I have to undo everything and redo everything. Okay, so that is that side. And now I'm going to connect this up to my wire lugs here. Great. Okay, so we now should have enough infrastructure here to do a full switched systems check. Goes to ground. Okay, that's power. So this switch allows me to power and utilize and separate 2 completely different circuits. Okay, so I guess there is operation. I'm going to plug it in and see if anything sparks. I know that's not the standard protocol. There we go. All right, nothing has sparked. Okay. Nothing. I'm not getting anything. Okay, so I've done something wrong. What have I done wrong? I've got power coming in. I probably don't have it. I probably don't have this set up correctly. Let me just double check this switch. Ah, right. I did have it wrong. Okay, so I'm unplugged. It's just those two. That one does not figure in. Okay, so let's just double check. Let's put that into neutral. Plug this in. There we go. So, power's off. Power should be on. There goes the vacuum. V. Okay, so I'm going to mark that. V. And the heating element. Let's try that. And I hear it. And when I turn that off, I get nothing. Hey, we have perfect operation. So I'm going to unplug this. Excellent. And now that it's unplugged, I can feed that through there. I can feed this through. Oh, you know what I want to do? I have one more thing. This thing makes too much noise. I'm going to get some foam and stick it inside. I have now lined the inside of the box with some soundproofing foam, so the vacuum shouldn't be quite as noisy. I've used a T50 stapler to hold the foam in place. I've got my switches threaded out through the front. I've laid down some VHB, very high bond red-headed tape here, and I'm about to put this on and test operation. Once we have that, well then, it's time to do the thing that I thought would be the total of today's operation, building the frame. But that is going to take the rest of the day. It's already like 2 o'clock, and that's going to be like probably a 2 solid hour operation. All right, here we go. we're there, actually. I think we're there. Here is my frame. Its construction is relatively straightforward, 1/2 inch thick, 32 thousandths wall square tube. The hinge is put on with rivets instead of welded. That gives me some adjustability. One of the tricks about a frame like this is it's got to hold a piece of plastic like this perfectly all the way around the perimeter. And so what you want to do is you kind of want to preload it. So I attached these hinges so they were slightly less far apart than 2 layers of the foam I've got lining these jaws. The foam helps to hold on to the plastic. And then when I put a piece of plastic in here, it should allow me a really nice amount of clampage between these 2 duckbill clamps. There are a million ways to clamp a vacuform frame. There's no need to get fancy. This little duckbill works just great. I'm just going to clamp on that and that'll hold everything. So I also laid down a layer of rubber here around the perimeter. So in every way, when I put a piece of plastic in here, hang on. Oh, that's some thicker styrene. I put a piece of plastic in here and grab onto it like that. And then I bring that up there, and now I'm making some vacuums. Wow, I actually put too many magnets up there. Okay, so I think I can go with half the magnets. I think I can go with half the magnetage. Let's see here. I'm going to crack these in half. Nope, that doesn't work. I thought I'd be able to smack them. Yeah. Neodymium, very strong, very brittle. Oh, ow. Let's see. Yep. Time to bring it down. And still, I feel like I could use a little less hold down pressure. That's impressive. Okay. At any rate, I think we can pull a form. Heat. It's starting to happen. Okay, let's blow this off. Up. Get a buck in there. Get some cornstarch going. Heating element is heating up fairly evenly. Okay, that's a good sign. Oh, I need to get gloves. For sensitivity, I really like these TIG welding gloves. Lincoln makes these, Tilden makes them. All right, so you can see under here, the same thing I was talking about before. The plastic is wrinkling and now straightening out as it's heating and being uniform. Yeah. Can you see the heating? Yeah, you can see the heating elements in there. Yeah, they're all nice and red, glowy, glowy. It's great. I'm not sure I'm going to let it get as far as I let the last one get. One of the reasons you get webbing is if you have too much droop, it's got to go somewhere. So I'm actually going to try less webbing this time. Sorry, less droop, to see if I can't take care of that webbing problem. I have other techniques that I can use to also get rid of that. You know, the foam liner that I use to hold in the plastic, it is basically just an 1/8 inch neoprene, self-stick neoprene on a roll. I bought this on Amazon. This is a thicker neoprene. This is rubber sheet adhesive. This is also a foam neoprene. I'm using that for the base around here. And they wear out. Make no mistake. Those rubber gaskets wear out, and you got to remake them every few months, every 40, 50 vacuum forms, something like that. All right, we're getting some good droop. I kind of want to try it. Yeah, let's do it. All right. Okay, here we go. We're going to go. So now remember, I've got this one switch. All I have to do is pop it down, and all of a sudden the vacuum is on. So I'm going to go down like this, over, and the vacuum is on. And Okay, still a little too much webbing, but that's awesome. I'm gonna cool it down now. Turn the main power off, unclamp it. It pops right out. It's ready to go again. This is great. I'm super happy with this. I'm going to try another one. I'm not going to start heating it up right away, but I am going to get another one loaded so that I can do this again once I have this one cut out, because, there we go. Because I want to try even less droop than that. There are a bunch of ways to cut out a vacuum form. You can run it on the bandsaw, but that noise is really horrific. I mean, it's kind of sometimes the only way you can do it, really. But I like to use the X-Acto blade because the sound of the bandsaw cutting through thin vacuum form styrene is like, that way lies madness. It will make you totally crazy. When you vacuum form, you end up with a lot of this crap. Plastic you don't need anymore. Sometimes you have to cut a form to get it off the buck, and then you just glue it back together, or you back it with a little extra styrene around the fix. It's moving. It's separating ever so slightly. Yep, and it's patience, really. Everybody who has to do this for the movies will tell you it's just about patience. And then you get nice forms out. Look at that. Okay, so I got 4 webs. There, and there. And I don't want them. The thickness around the nose is better on this one, so less droop is great. But I have another technique for getting rid of some of those. So give me a sec. This here is my solution for getting rid of the webs. It's basically a shape I put down. You'll see how I do it when I'm actually executing the vacuum form. I put this shape down, and it effectively pre-stretches. So what happens is I'm getting webs here and here, there and there, because there's too much material. It doesn't have anywhere to go. So what you can do when you have that is you can make a box that pushes down on the plastic and sort of pre-stretches it. So you've actually removed some from the equation. I still want to pull out a little bit more. Yeah, up there. So vacuum forming is used in industry to make packaging for toys and products. And you've seen vacuum form packaging. And vacuum form, when you do it in a factory setting, they use these things all the time, these pre-stretchers and helpers for forming. In fact, sometimes there's even an underbuck and an overbuck to help place the plastic over the underbuck. I don't know that's called an underbuck, but you know what I mean. Turn on the heat. I really should have a light here, but that'll be a later iteration. I'll get a light on that tells me that this thing is powered up. Main power is on. Heater's heating. Getting this. The central message here is that every vacuum form is a little bit different. It's never trivial to get it all working. Couldn't keep watching my hair fly away. Get my hair cut soon. Plastic, as you can see, is bowing up the way I said it does. I feel like I kind of want to try this. It's literally like half an inch past the bottom of the frame. Do I really want to try this? Yeah, I really do. I do. I think I want to try it. Okay. See, this is also where I've got 3 things going on. I'm going to drop that, put this on, turn the thing on, and I don't want it to last too long. I don't want to take too long to do it. This is where having an extra set of hands helps. But COVID, so no go. All right, here we go. Let's try it. Down like that. Still got a little bit of webbing, but much less. That was an improvement. That was an improvement. Ooh, that's gross. That is some artifact of some of the cornstarch there, I think. All right, let's cut this out. Let's try another one. I have some ABS here. ABS tends to stretch a little less, which makes it kind of a pain in the ass to use, in my opinion. But at the same time, it might be great for this. And also, yeah, I've got this thick ABS. This could be amazing. Let's try the thick ABS. Fun. I hope you're watching this. I hope you've taken this trip down memory lane with me. If you have, oh, crap. So okay, this happens. I'm using plastic that's a little thinner. I got tons of this stuff. I've got like 040 and 060, and really I should be running this out of 80 thousandths or more. So I have a crack up the side here. Wait, where is it? There it is. I have this crack up the side. That'll make it easier to get this to get the buck out of the form. And like I said, sometimes you make a cut just like that in order to facilitate the release. And it really, styrene is so, it's so gluable and so sandable and so workable with weld-on and with cyanoacrylate glue. Yeah, I went way too far in the cornstarch there. Showed up. Anyway, that's an easy repair to make. You simply add some styrene on the back side, then you take a sanding stick and sand that down. Those webs disappear pretty fast. All right, let's start heating up this ABS. I don't work with ABS a lot. I have found it to be consterningly peculiar to work with. But I really, this was a important piece of my employment back in the early aughts when I was doing freelance work. And every time I saw the droop of my platform, I wanted to add in those fins and never got around to it. So it's really nice to do that right now. Yeah, I guess with a texture, I guess you could call this 80 thou. I don't know. The texture here, it's got a texture on one side and it's shiny on the other. A lot of times the texture hides crimes, right? It makes bad details disappear to a certain extent. I am still running the texture on the inside here, which coincidentally should make it a lot easier to remove from the form once I'm all done. Plastic's getting softer. What's nice is that the heating element was not heating up uniformly, but that's because some of it was touching the fireproof backing and some of it wasn't. And stuff that was touching was getting its radiation radiated back on itself, so it was more powerful. But now that I've got it in sort of this hot box, well, now it is heating up really nicely. The thing is that it takes a long time to heat, which means I'm also kind of melting the things that are holding on to it. This is the whole thing. One thing that I like about my vacuum former is that this doesn't get too hot. It gets hot, but not too scaldingly hot. The heating element is always going to be one of the more difficult parts of vacuum forming. But actually, to be honest, if you want to seriously try some vacuum forming, go onto YouTube. There are people who have done magnificently beautiful costumes using a vacuum former that is a garbage can lined with tin foil with a space heater at the bottom and a wooden box with a vacuum inlet for your shop vac or your house vacuum. The amount of pressure you need to make a vacuum former is very small. Overall, it's what is this? Probably like 1.5 psi, but across the whole form, that's like many, many pounds. Yeah, ABS, man. It's not heating. It's not moving uniformly. I've got this sort of weird cleft back here where it's not perfectly heating. And this is my experience with ABS, is that as it moves away from the heater, and now I'm starting to smoke. See, I'm not sure I love this. Everything's starting to smoke. That could be just the dust. It's burning off the top, but I kind of, all right. I think we're gonna get this shot. Let's see if I can pull it down. Yep, there we go. Oh, that is ugly as hell. This is why you want gloves, because it's still soft around here and I'm helping it get into all the corners. It's not giving me a good vacuum form though. I mean, I guess one could salvage a form out of this. There we go. That was okay. It's just all right. I mean, it's heavy duty. That's something I do like about it. Oh, okay, here's the thing. When you have a big, heavy piece of plastic, sometimes it makes it much easier to pull the buck out. This whole thing just creaked on me and told me by that creaking that it's going to release. That's neat. Oh, come on. Yeah, I guess, yeah, somebody could make something out of that. I don't want to try ABS anymore. I don't like ABS. Heating up. That was great. So for the record, this is the hero and correct shell part for Ghostbusters Ecto Goggles. And this is what I made after about 3 hours of labor by using this wren-shaped buck and pulling hot plastic over it. Now you should know, if you don't have access to wren-shape, LDF, what's often called TruePan or low density fiberboard, is not only a sustainable growth product, it has no formaldehyde in it, which is great for certain shops, and it can do bucks all day long. It's great for bucks. MDF and LDF are both fantastic for making vacuum form bucks, and I've made hundreds of them with that stuff. The wren shape is the fancy stuff. But Deuteronomy, I'm really, that is a highly respectable bit of kit. Now I may end up, oh, right, how did I fix the webbing? I wanted to talk about that. So I had a web here, and as you can see, I still have a little sanding to do, but the web is gone. So what I do is, when I pull the form off the buck, I've got a little crease in the back where the webbing, where the inside of the webbing is. I fill that with cyanoacrylate glue. Can you see that? Hold on. There we go. I fill the backing with CA glue, and then I dribble on a little bit of baking soda. Baking soda is an insta-kick for CA glue. You can use accelerator like this, or you can use zip kicker. Cigarette smoke works, but ish. Baking soda is phenomenal with CA glue because it adds body. So I use it specifically for things like this where I want some, I don't want the brittleness and the hardness of the acrylic glue to work itself away from the styrene, and the baking soda helps me make kind of a monolithic little repair in there. You can see just how much CA glue I've put in there to support that, and I've done the same on the other side. This is a standard thing one has to do with vacuum forming. Once I hit this with a coat of paint, you'll never know. You will never, ever, ever know. It is, look, there are some people who are great at vacuum forming. I am just like everything else I know, I am mediocre at it. So I have to learn how to fix things instead of how to do them right the first time. That is great. I am not going to continue on right this second making Danny Aykroyd's Ecto Goggles, but at this point I can make several. Look at that. Yeah. Even the very first form is still quite serviceable, except for this giant web, which I've got to take care of. These three are all okay. Yeah. I really love that comparison. That comparison. I know these are gold and these are silver. I am not even sure what the actual color of these is supposed to be. I think it's black. And maybe you have to pull them off. Maybe I'm forgetting. I just wanted to make this look exactly like that. I haven't gone back into my Ecto Goggles reference library, which will tell me a lot about the next steps for this. But here we are, replicating a piece of industrial equipment. And to boot, my beautiful old vacuum form machine is back up and running. Again, the origins of this vacuum form machine is that my model making mentor, Mitch Romanowski, who ran the shop for Nightmare Before Christmas and also for James and the Giant Peach, and was one of the most intuitive modelers I have ever met. That guy was a problem solver par excellence. He had his difficulties, don't we all? But Mitch was an amazing, amazing guy to have as my first real mentor in this industry. And it makes me feel, Mitch died a few years ago. He is survived by family and friends who love him and remember him fondly. And this is my way of remembering him. Yeah. Thank you guys for joining me for this one-day build. I did not expect my vacuum form machine to be pristine and up and running in new shape at the end of this. But I'm really pleased with how this went. Thank you guys for joining me. I'll see you next time. Thanks for watching that video. If there's a video equivalent of the Clean Plate Club, you're a member. If you want to support us, one of the best ways you can do it is going to our merch store and purchasing one of our beautiful new posters. This is my hand-drawn sketch of my two toolboxes that I used when I was an active model maker at Industrial Light and Magic in the late 90s and the early aughts. There's also on the far left side of the poster a list of all of the tools I had in these toolboxes, and I used them daily for almost a decade. Again, you can get your own version of this printed on a beautiful cardstock by following the links below.